So we're going to start talking about input and formatting some output in this chapter and getting more complicated equations. So we have to talk about like order of operations and some of those things you heard in math class. But I'm not trying to confuse you with making really complicated math equations. I'm just trying to make sure you understand the basic rules. So I try to keep the math equations fairly simple. And so I'm not trying to trick you with that, just trying to make sure you understand the order. So we use something called Cout to get output to the screen. So we're going to start taking an input, which is Cin. So Cout is output, Cin is input. The arrows just go the opposite way when you're doing it. But in order to take in data, we need to have a variable to store it into, because when we're taking in, we need to save it somewhere. So we're going to have a variable. Hopefully you've heard that keyword variable before in your math class. And we need to give our variable a name, except we need to do a little more than that besides give it a name. We need to tell C++ what data type it is. And so a data type tells it, is it a number? And if it's a number, what type of number? Is it a decimal number? Is it a whole number? Is it text? Is it one character? What is it? Okay. We already have that IO stream for Cout, so we don't need to add anything special for Cin. And so that IO stream is going to be on every single one of our programs, so we don't have to worry about doing anything special. So if you take a look at this example program, the program calculates the area of a rectangle. It wants to know what is the length of a rectangle. So here, these are all Cout statements, but this is a Cin statement. So you see the arrows go the opposite way. But you need to have this variable, what we call declared or defined up above. So make sure the program goes in order, the code. So before you can say Cin and put it in a variable, you have to have told C++ what that variable is and what data type it is. So int means whole number. If you ever heard of integer, so integer is a whole number. If you know it, or if you think it might be a decimal, don't go with int. Only if you're positive it's going to be an integer or you want it to be an integer, go with that. If it's going to be a decimal, we'll go with double, mainly in this class, okay? And then we're going to say, what is the width of the rectangle? We could take in the width. We have a width up there. And then we could do a basic calculation. We talked about that last time. So we have the variables to do basic calculations, right? So we have an area variable. We multiply the length times width. We save it in area. So just a simple equation, and then we print out the answer. So hopefully you're all okay with, declaring our variables and, doing equations, basic equations from last time, and then printing out the answer. Is everybody okay with that? And the only thing new is the Cin, right? So the Cin makes sense to everybody? Okay. Okay. So here again, it's just an example. Before we can take in the height, we need to have a height variable declared up here. Okay, and we need to just determine what data type we're working with. What do we want to take it in as? We could take it in as a double, or we could take it in as an int. We do need to make sure whenever we do a Cin that we always have a Cout first that lets the user know what they're supposed to be typing, because otherwise you get a little blinking cursor and nobody knows what to type. And so always make sure this is kind of like your label, like what are we supposed to be doing? And then the blinking cursor to tell you to type. By the way, if you do a Cin and you never go down to like where the output is and click and actually type something, it will run for eternity because you never typed in the data to go to the next point. So the program won't go to the next point until you actually enter data and hit enter on your keyboard. It just keeps running. It's waiting for you to input. And if you don't input, it never stops. So, okay. You could take in multiple, I don't typically do this, but you could take in multiple values at the same time. And so you'd have to just make sure that when you input them, you do with a space between them and you put them in the right order. Although if you're doing area, it just multiplies them together, so it doesn't really matter. But if it's something else that the order matters, just make sure you type in the values in the right order. That's why I don't typically do that, because if you put them in the wrong order, it doesn't work. Okay, so in this example, you can see it says enter the length and width separated by a space. And so when you enter them, the first one will go into length and the second one into width. And then it's the same exact program. Okay. So this one, same thing, it takes in 3, and it can actually have 3 different data types. And so this one has a whole number, which is an int, a decimal, so that's a double, and then it has a char. A char is a 1 character, and so it's actually single quotes around it, but it can only be 1 character. If it's more than 1 character, then it's actually a string. So in this case, it's important you enter them in the right spot, because if it tries to put like the char into the int spot and it tries to put them in the wrong variable, it'll get messed up because it doesn't have the right variable type. So like if you don't enter them in the right order, like it says enter integer, double, and character. If you enter character first and then integer, then double, it's going to be all messed up because they're going to go under the wrong variables. So that's why I don't typically do that. But you have the possibility because if people don't always read the order and put them in the right order, right? Okay, everybody okay so far? All right, so hopefully pretty easy. And if you just look at a previous program as you do it, you'll eventually have it memorized. So we can get more advanced equations, and this one doesn't talk about order of operations, but it actually just multiplies 2 times pi and then that answer times radius. And so you can keep going with it, but we do need to talk about the order because the order is going to matter in certain situations. You can also put your equation right into a cout statement. And so this would just do it and not put in a variable and just display the value right there. So that's another option. Okay, so order of operations. First, if you have any type of negative, that's going to happen first. We don't typically work with negative numbers, but every once in a while we do. And then if you have any parentheses, that's always going to happen. If you have inner parentheses, that's going to happen first, and then outer parentheses. But if you don't have parentheses, then it jumps to the next level. Yes?
That equation, did you put a minus in front of the first two? Would it like do that first?
Mm-hmm.
It wouldn't get an error or anything?
No, yeah, you can do it.
You have any parentheses in it?
Yeah. Yeah.
Cool.
So this one wouldn't do the 2 plus 2 first because that's not the right order. So multiplication, division, and that modulus, that one that's like difficult for people to remember the remainder one, that happens first. Now they happen from left to right. Okay, so these are all equal, but that happens from left to right. So if it hits multiplication, because it doesn't do addition or subtraction until after. So it would do the multiplication first. It only works with 2 numbers at a time and solves that and then goes to the next 2 numbers. So when you're doing it, just do 2. So this would give you 4. And then you would add the 2 plus the 4 to get 6. And then you would subtract the 2 to get 4. Let's see that. You can do it in your head, or you can write it down and just do 2 numbers at a time. We're going to practice a bunch. So let me. I want to get my notepad up here so I can. Because I'm trying to put it on the video, so if I write on the board, it doesn't get the, I can never get the, there's like a camera thing. I can never get it to face the board and be clear and, so I don't even really try. I'm sure if I practice enough, I could get it, but. Okay, so if we look at our expression here. Oh. Okay. We're going to look at these equations and talk about them, make sure everybody's good. So if we have 5 plus 2 times 4, we are going to do the 2 times 4 first. Does everybody see that? And then we're going to just put 8 in there, and then we're going to add the 5 and 8 to get 13. Everybody good with that? If I solve this to be 13? Okay, awesome. Okay. Then 10 divided by 2 minus 3. So this one actually goes in the order because that happens to be the first thing there. So 10 divided by 2 gives you 5. See, I try to keep it. I'm not trying to trick you with the math here. And then replace it. And then 5 minus 3 gives you 2. So this one would be 2. Does everybody see that? Awesome. Okay. 8 plus 12 times 2 minus 4. Okay, I don't want to do this because I'm not there yet with the order of operations, but I'm going to do this first. So I'm going to get 24. Everybody see that? Okay, and then I'm going to go back to the beginning because they're all at the same level now. So I'm going to do this one first. Everybody with me? Okay. And then I'm going to subtract. I'm going to get 28. Everybody good? Okay. 4 plus 17. Modulus, there goes that modulus. Everybody loves the modulus. So I don't want to do this because I'm not there yet, but I would solve this first. So 17 modulus 2 means just how many times does 2 go into 17? So you need to figure out what the remainder is. So 2 times 8 gives you 16, right? And then there's 1 left over, right? So this would be 1. Does everybody see that? Is it okay with that? Okay. And then I'm going to do this. And then I'm going to subtract and I'm going to get 4. So So the answer to this one would be 4. Did y'all follow that okay? Okay. 6 minus 3. And I'm trying to record this, so if you need to go back through and practice these problems, and you need to pause it and see if you can get the answer before I give it to you, fine. And this is a great thing to ask ChatGPT. Can you generate me some math equations and see if it'll, and then ask it for the answers, but you try to solve it before it gets the answers for you. Okay. So this would be first, right? Because the order of operations tells us that this would be 6. And then we would do this because they're all the same level. And then I would do this. And then it would do the last step, which would be 6. Yeah, okay. All right, so the answers are right here for you, but I kind of hid those from you. Okay. So you have to be careful because if you put parentheses in different places, you get different answers. So it's amazing because you're multiplying the 2 times 2 here first, you would get 4 for this equation. But if you add parentheses around this, you add first and then you get 6. And if you put the parentheses over here, it ends up being 2. And if you put both sets of parentheses, you can get 0. So depending on what you do, you can get completely different answers just moving parentheses or not having parentheses. Okay? So same idea. Whoops. Just make sure everybody's following. Okay. So now we added parentheses in there. So I know I mentioned these, but I didn't have any with parentheses before. So we would do parentheses first, right? So that would cause me to do this. And then I would do this. And I would get 28. Everybody's good? All right, 10 divided by 5 minus 3. I would do parentheses first. Normally I would do 10 divided by 5, but because it's in the parentheses, I would do that and get 2. And then I would divide and get 5. Okay. 8 plus 12 times, and then I got the parentheses again. Because I have parentheses, I'm going to solve that first. So 4. And then I'm not going to do this. I'm going to skip to multiply, right? 60? Is that right?
48.
Am I right? Oh, 48. Yeah, went too far. Thank you. And then I'm going to add these two together to get 56. Good. And then the last one. Oh, no, 2 more. Sorry. Okay. 17 modulus 2. Okay. So do 14 plus or 17 plus 4 because it's in parentheses, right? So 21. Pretty good. This one, you are going to do this first. Modulus means remainder. So if you take 2 into 20, it goes 2 times, or it goes 10 times, and then you have 1 left over, right? So 1 would be the answer. Does everybody see that? Okay, and then just get 0, right? Okay, and then this one has a couple parentheses, so we need to be careful. So we are going to do, if we have a couple parentheses, we start on the left and do that set of parentheses first, okay? So we would do this set of parentheses first and we would get 3. Is everybody following? Okay, and then we would solve this set of parentheses and we would get 9. Are y'all following? Okay, now these are all at the same level, so we would have to start here. Everybody okay? All right. And then, am I losing my mind today? I would get the integer version of that, right? Do I need to do a decimal? I guess, no. No, I'm losing my mind. I swear I am. So my kids have been keeping me up really late at night and I'm not like getting my sleep. I'm sorry, guys. So 9, yeah. That divides evenly. I'm sorry. I try to keep it simple. All right, are you guys all good? All right. If you need to use a calculator, you can. You shouldn't need to if you're able to focus. And I try to keep it pretty simple. And you can use scratch paper too. So like for your quiz, you can do as many times as you need. But for your midterm, if I ask you questions like that, You can use scratch paper, so if you need to just like jot it down. If you do it in your head, sometimes you maybe skip a step or you don't keep the right tally, but if you can do it in your head, that's completely fine, but if you need to write it down, you can, so you can do step by step. So scratch paper on the midterm is good. Okay. You cannot put variables next to each other like that and just assume it's multiplication. So you need to put the asterisk for multiplication. Okay. You cannot put it like this. You can't, you have to write it like, this is the power of, there's actually a function called POW, which stands for power of. And so you would do like s to the power 2, you can't write it like that, okay? You can't write on, you can't put like it on top of each other like that, so it would be written like this. So those normal math, can you see what's up there? The normal math equations like that are just written a little differently, okay? All right, so just to show you, like this would just be an asterisk. And then you can't do this either, like the parentheses, you have to do an asterisk. Same thing. Everybody good? Awesome, okay. You can use float if you want to, but really the space that you're saving isn't all that, important. I mean, not important, but if it's critical, then do it. But because we're just starting off, using double is easier to work with, because if you get a double in your equation, the whole thing ends up being double, and then it won't save properly into a float. And so floats can be more difficult to work with. And so usually we just typically go with double. You can have unsigned, which means you don't want to have the negatives. If you want to force it to not have the negative, that's a great way to do that. Then it won't allow the negative number. Okay. The doubles at the top, and so it's going to take up the most space. And so you can always put like float into double and int into double, but you don't want to put double or float into int. And so you can go from the smallest to the largest, but not the other way around. If you ever think about like containers, you can always put like something smaller in a larger container, but can't do the other opposite. Yes.
Wasn't there a way you could say like long or something? Without being bigger?
Yeah, I just don't, yeah. And we're not even gonna use long in this class. You can use, yeah. We won't use numbers that large, but yes, there is a really long. Sometimes strange things can happen. You probably won't have this happen because you're not using numbers that are that large. But if you go out of the space that's allotted for like an int, like there's a range of like the negative to positive than an int can be. And if you go too large for an int, it actually flips back around to the negative side. And so we call that overflow and underflow when we flip from negative to positive and positive to negative. So just to show you, get this thing to end. Okay. Hold on a sec. Okay, so if you don't have to do this, you can just watch. I'm gonna put just to make it look the same as I always have, then I can get, if I do an output, I just have to do C out. So if I have a variable that is large and outside like the range of what a variable should be, like I'm gonna do 2, 1, 4, 7, 4, 8, 3, 6, 4, 7. And then I'm gonna have another variable where I say I want to add 1 to that. Okay, and then I'm gonna print the answer. Like what is B? It's gonna be too big because to fit into an int, so it should flip it to a negative number. See how it became a negative number? That normally adding 1 to that wouldn't be a negative number. But the reason I got a negative number, and again, we're not going to use numbers this big, is because it can't fit in the range. It doesn't know what to do with it. So C++ just takes it to the opposite side and just like starts working back to the negative.
So would you do the overflow error?
No. C++ is doesn't give you like the Java will do that kind of thing. C++ will just fix it whatever way. So like in an array, if I don't if you've heard of an array, you have like a list of things. If you go too far in C++, it just pulls the next thing in memory. It like doesn't stop it from going. And if you don't initialize the variable and you try to print, like if you set up a variable, you don't put a value in it, a lot of people think it defaults to 0. It's just garbage. And then later you put an equation and you get garbage answer and it's like I never put anything in that variable, but C++ doesn't crash or tell you that you never put anything in, it just puts garbage in there. So like, if you don't put anything in there, you get garbage. So if you get a garbage answer, it's because something weird and you need to figure out, like, this is, you need to know that number, again, we're not gonna use numbers that big, but that number is too big for an int, so we need to step it up to like a long or something, yes.
But what would happen instead of +1, you did ×2?
So that's, it will do, I think it'll still do negative, that's a great question, let's see. Well, yeah, it does negative, so it just, I can't go that big, so it reverses
It's
that.
just small though.
And it does the, so if you do a negative and you subtract, it goes the opposite, it'll be positive. So it just like overflow and underflow, it does the opposite. It's weird. You won't have that happen probably because we're not going to do numbers that big. But if you ever did, now you know why. It's kind of cool. Sometimes that's like problem solving. Why didn't it do what I wanted it to do? Like, why did it give me this really weird answer? So the other day I told you we were going to talk about casting. And this is, you know, a way that we're going to cast it. So if we are doing integer division, and we talked about the problem with that, sometimes it's good, but usually it causes problems in our equation. So if you're dividing two numbers and they both happen to be integers, your answer is going to be integer, which means whole number, which means going to chop the ending, right? So we need to cast it if we want them to, you know, either we can fix the two numbers and make sure that they're not two integers, that we change the data type, make one double, or we change the number in our equation, make it a decimal. But if we don't want to do that, like let's say we were taking two things, like the number of questions on a test and the number you got right, and we don't want to force it to be double because it's not supposed to be double because those are typically two integer numbers. So we don't want to just force it to work. We can do a static class. So if the two numbers you're going to have are going to be integers when you're doing the division, so if this is going to come out to be an integer and this is going to come out to an integer, what you can do is you put static cast to what data type you want to cast it to. And it doesn't always have to be double, it can be float or whatever you want to cast to, but double's typical because that's what we are usually using and that's what we usually have a problem with. And then that will cause this to cast this as a double, and then when it divides, you'll get a double. Okay, so it's like temporarily forcing the data type to be something different for the division just fixes the integer division problem that we have without changing the data types of the variables. That is one way to do it though, but some people don't like to change the data types of the variables because maybe it doesn't make sense for what you're doing. And so this is a different way to do that. But you don't have to always pack their double. Like this one changes a character to be an int. So characters actually have you know, ASCII values, and if you can change them to be an integer. And that's how you can actually compare characters. You can say like this character is greater than this character, because there's actually a number behind the scenes that it's comparing. And so you can see what that number is if you put int in there, if you cast it. Okay. All right, so this one is a great example of maybe us not wanting to change the data type. And so how many books do you plan to read? This is an integer for books. And then how many months will it take you to read it? This is an integer. Maybe I don't want to change these two, right? I want them to stay integer because it doesn't make sense to make this a double because you could read like half a book, but we're only going to count it when you're finished. And then we're not going to say like a half a month. We're just going to say like a full month. So instead of changing the data types, you put static cast double. And then when you do the division, now you want to put this so that it casts this and then divides it. Okay. So when it just changed books to be a double and then divides it, and then you come up with a decimal. Everybody good? And you could change the data type too. That's another way. So, all right. I have another slide that kind of shows you a shortcut of this, but sometimes you want to take like X and add 4 to it and replace X. So what it's doing is it's always going to do the right hand side of the equals first, like whatever the equation is, and then put it back into the variable. But you can put it back into the same variable if you want to. And if you find that you're doing that, there's a shortcut for it. Like if you find that you're repeating the same variable twice like that, then there's a shortcut. And so if you see how it's sum and sum, you're taking the sum, adding 1 to it, and then putting it back into sum. So this is one shortcut for it. If you're just doing it by 1, there's even another shortcut. It's actually sum plus plus to add 1. If you it only works with 1 though. I know it's 2 plus signs. but it's actually just adding 1. So this equation works for all numbers though. If this was a 5 here, this would just change to a 5. If this was like a multiplication symbol, this would change to a multiplication symbol. So this type of shortcut works for no matter what you do here. You just take the variable, the operator equals, and then whatever number or whatever variable you're using to change it. Okay, but if you are doing it by 1, there is that plus that you can do. And if you're subtracting by 1, there's a minus. But any other number you want to do or any other operator, you have to write it the other shortcut way. But they're all equivalent. Like whether you put sum equals sum plus 1, or you put sum plus equals 1, or you put sum plus plus, they're all the same. They all do the same thing. So it doesn't really matter. If you're ever wondering like where C++ came from, there is a version of the language called C. And then they added more features to it and it became C++, which is like the next version of C. There is no C+, it's just C and C++. There's a C sharp, but that's not. Okay, so C and C++, it means that C was like the next version of C++ is the next version. Now, we're actually not doing any of the object-oriented features that C++ has, which was the new features. We're really just using, you know, the procedural things that are in C. But we could, like if we kept going with it, but in your next class, we use Java to do object-oriented instead of C++. But C++ does have the capability to do objects, and C doesn't have that capability that C++ does. But we're not using all the capabilities. We're kind of staying at the very minimal. Okay, so here's the shortcut that I was talking about. This doesn't look that long, and you're probably wondering why they shortcut it in the first place. But if the variable names were longer, it makes more sense than having to write it twice. And you may say, I'm never going to use these shortcuts because this makes more sense to me. And that's fine, but if you see people use them, you need to know what they do because other people might use it in their code. And typically, whenever you code, you're not coding alone. You eventually have to work with other people. And so the more you see it, the more used to it you'll get. But at first, you're kind of probably like, that's kind of confusing. I don't know if I'm going to use that, but just know that that's the shortcut. Does anybody have any questions? Okay, perfect. We can format, so you probably realized that some of the output we had a really long decimal number, and maybe you wanted to shorten that to like 2 decimals, or maybe you wanted to change like the spacing of your number. So you can change like the justification, and you could change like the number of decimals. So you have to put this preprocessor at the top, IO mana, to do that, and then you can change things about it. So there's one called set W, and it'll set the width. So it stands for set width. And then you put a number in there for X, and that's how wide it's going to be. So if you look at this, you can see that first you have to have this include IO mana up here, and then you can do on your CLs, you can do a set W, and you can put how many spaces you want to have. It's kind of like hitting tab or like hitting spacebar a bunch. You could just put quotes with the number of spaces you want, and that would do the same thing. But the thing about hitting space inside the quotes, you can't really see how many times, and you might hit it 4 one time and 5 another time, and maybe it's not lined up right. And so it's kind of, if you're just hitting space bar inside quotes, it can get hard if you want to add a space or delete it to forget. And now you know they're all the same because they're all 6 instead of just doing it manually. So, okay, and because they're all justified lining up that way. All right. There's a couple different ways to do this, and I'm going to show you different examples of it. But we could do set precision or show point. I usually use set precision, and I'll show you the difference. But you can pick like how many decimal places. So typically use 2. But show point is going to also count the number of integer numbers we have, whereas set precision only counts the number of decimal numbers. So if you wanted your number to have the same number of integers and decimals and for all, which typically you don't want to do, but if you wanted that, you could do that, and I'll show you the difference. But here, I think I have it on the next slide. So this is taking a data for day 1, 2, and 3, and then adding all those days together and saving it in a total. And then on the next slide, we can see that we have the different days, and we're printing it with set width, so we can get the spacing right here. But you can also see that up here before we started, you did a set precision of 2, and then 6 meaning you're gonna have 2 decimal places, and then so each of you has 2 decimal places. It will round. So like if, you know, if that third number is a high number, around that second number up. Okay. You can do left or right justified if you want to change that. And then I think I'm gonna go ahead and show you this. And so let's go ahead into before we go further. So let's go ahead. Actually, I'm gonna practice that static cast and make sure everyone's okay with that too. So if you want to practice this or you want to watch, it's fine. I already have an A variable and the B variable. So I'm just gonna make A3 and B4. And we know that if we divide these two, we're going to get, whoops, that's supposed to be A. We would just get the integer, right? Because they're two whole numbers. Okay. So we just get the integer 0. Normally that would be 0.75, right? But if you divide with two integers, everybody see the problem? Now, before I told you just make one of them a double and it'll fix your problem, which does fix it, but may not be what you want to do. And so you get 0.75. Only one of them has to be a decimal for it to be a decimal. But that might not be, you might say, I don't want to change the data type of this. So how else can I fix it? Well, you could do the static cast. So here what you would do is you put static underscore cast, and then put in the greater than less than symbols. You want to put double. And then you want to cast A to be a double. Okay. And then it will work. But if you don't, again, you get 0. Oh, but I didn't have to change the data types. Everybody okay? Awesome. Okay, so that is casting. And now I want to show you, I'm going to leave my two variables here. So we'll do 3 and 4, I guess. And here I want to show you the printing of that. So if you want to do set W, you do have to add the item man up. I'll do it in just a second. And if I say I want to print A, and then I do want to do set W, and I'll do another 5, and then I want to print B, just to show you what that looks like. But I do have to add a preprocessor up here. So we'll say include IO man up. Okay. And then that'll give you like tabs or like spacing. So the set W gives you spacing. Okay, are y'all good? Okay. So if I leave that IO man up, I can also use it for decimals. So if I do like A is 3.4, let's say, okay. I don't need a B. We're gonna just say we want to print A, but I want to do set precision. 4 places. I'm gonna do show point and show you what it looks like, and then we'll do fixed. And then I need to put that I want A. So or let me see if I do fixed. Why isn't this working? I'm missing something. What did I do?
The variable.
Oh, thank you. I told you I'm a little out of it today. Thanks. You gotta help me out, Steve. Okay, let me put show point back. Doesn't work. Yeah, okay, thank you. That should have done it with show point, but I thought maybe I'd try fix or it's not working with anything. Okay, so show point is if you say 4, you know how you don't have 4 decimals though, you have 4 numbers. Like you have a whole number and then 3 decimals. So it includes the integer numbers and the count of how many numbers you're asking for. Which is kind of a strange way of thinking about it, but it might be what you want. But typically, when we think about having like 4 decimal places, like if I said I wanted 4, I would put fixed, and it would look like 4 decimal places, right? So fixed means you'll get that number of decimals, and it doesn't matter what the whole number is. Show point means that includes the whole number and the count for how many. Yes.
What do you put both?
I don't know. It gets confused. I don't know. Hmm,
Stays fixed.
yeah, maybe it matters which one you put first. Like, I'm ignoring the other one. I don't know. I never tried to do both. Hmm. It defaults to fixed, I guess. But you have to pick which one you're, and if you just wanted two, you just make two. If you did have more numbers, of course, gonna round that number on there. And then there's also things you could do left or right in there, and it'll left or right justify, especially with like the set W, if you're doing like tabbing. That helps with like creating like more of like a table look. So we can try to line up our numbers however you want. Okay, so you might play around with that a bit and see which one you like. Okay, and I think that was, I left off here. Okay, so I'm gonna do something actually before I show you this. Just stayed over there. Because I want you to reason this. So whenever we're doing CN, this is kind of weird. So if I'm doing, let's say a string, name, actually, I want to ask the user for their name, like enter your name, right? And then I want to take in that name, and then I want to print out that name. So we'll say like name, your name is, okay. Then that should be fine. Like my name. Okay. Now, what happens if I do, see how it didn't get the second word? It didn't get my last name. Because when you're doing the CN, if you're only doing one word, it's okay. But if you're gonna do multiples, if you're gonna add a space in there, the space throws it off. Okay, it also throws off like if you're asking for multiple pieces of data, like if I'm asking like, what's your name? What city do you live in? When you get to the city question, it already filled in your last name with the city. Like it takes the last name and puts it in the city. So you don't get to fill in the city. Like if you're asking for two questions, because it just uses the space as like a delimiter to put it in the next variable. It doesn't take the whole line. So if you want more than one word, you know people are going to enter multiple words. You don't want to use CN with a string. You want to use getLine. Does that make sense to everybody? So that's what the next part was talking about is like CN works with like one word or with numbers and everything, but it doesn't work well with like a whole line. Anytime you're hitting spacebar or tabs or anything like that, you're causing problems. And so that's what this is saying. So I kind of tried to show it, give an example of what the problem is. And so like if you're entering your name, instead of saying enter your name and doing CN, you want to use getLine and do CN name. And then if you want to do like what city you live in, CN, and then city, whatever variable is used up here. So instead of CN with the arrows, you do getLine and then CN and then comma the variable name. So just a little different structure, but this is with strings, like with multiple words that you have problems. So if you know you're going to take in some answer that somebody could put two words for, then go with getLine. If you ask for a name, typically some people put in like first name, middle name, last name, right? And that's going to cause problems. Okay, so and then you output it the same way with the variables. So that makes sense, everybody? Okay, I just want to kind of show you the problem first. You can do other things with string. So talking about string, one cool thing you can do is you can ask the length of a string. The string is everything that's included in the quotes, and so that would include any punctuation or spaces that you put in there. Those also count as characters. And so when it's counting the number of characters, it's going to include that as well. So if you just say the name of whatever you put as your variable, that length, it'll count how many characters, and you can say that or print that, use that. You can join strings together. So like if you didn't have like someone enter their first name and their last name, you can join those together with what's called concatenation, which is the plus sign. Okay, and put it back in a variable. So if you wanted to like have them enter their first name and use a CN and have them use their last name and then join those together. And then make sure you put a space also joined with it, quotes, and just save it in like an overall name variable. You could do that and format it the way you want. Okay. There's all kind of cool math things we can do that we're not really going to use in here, but are available to you. So of course we're not doing like sine, cosine, but like square root's pretty easy to use, and usually people have used it before. So we can use that one, but there's all these math library functions. There's even more than that, but you might find useful. So if you wanted to use them, you would just okay. You have to include, I don't need this unless I'm doing formatting. You can leave it if you want to, but you have to add this include for math. It's called C math. And then you can do all the math functions that I was talking about. So if you had a variable that was like the number is 5, for example, and you wanted to use the square root, you could put it in a variable if you want, or you could just use it in the C out. So I could say something like SQRT, that's the square root of number, and it will tell me. But this could be input too. So like if we wanted to practice, since we've been doing that, maybe I should have you do that. I could do C in, actually C out, enter a number, and then C in, no. Oh. And then use that number instead of just putting in a number in there. And then if I do a number, then it should give you the square root of that. Right? Anybody have questions? You could try cosine, tangent, any of those two. Yes. Yours has what?
Mine hasn't been working the whole time. If you're saying C out was not clear.
Try this. Make sure you have. It should come with it, and make sure you have this IO stream at the top. It sometimes it might have got deleted. Usually it starts with that, but if maybe when you're deleting comments, it might have got deleted. You'll need that for everything, but the other ones, like sometimes you might have them in there and not use them. That's okay, but like try to, if you don't need them, you can take them out. So it's not just like overwhelming list of everything you could possibly do. If you're not doing math, take out the math one. But if you leave it in there, I guess it doesn't hurt, but just try to keep just the ones you need. Yes.
How come those don't need a little colon thing of me? The IO stream and CMAT, semicolon, I mean.
Oh, this one?
Yeah.
This is different. This one's like a just so you don't have to do the STD. It's like what they call a namespace, but these ones are preprocessors. So they are written up that one's not a preprocessor.
Like why don't they need the little semicolon?
Oh, I don't know why you don't need it. It's not really a statement, I guess. It's just like it's a way, like basically C++ has all this code, and that's a way to tell it, like go look at the IO stream code to know how to do C out and C in. But I don't know why they decided you didn't need a semicolon. It's considered not a statement, I guess.
Yeah.
But I'm not sure why they didn't write a statement, but okay, oh, let me go back and see. So again, you can try all these out if you want to and see what happens. Okay. So if you want to do random, you have to add this header preprocessor at the top. And so rand is going to return a random number. And so if you're trying to like do like a guessing game, it would be cool to like generate a random number and then have the user guess what that number is. And so it makes your programs more interesting. You can do like a rolling the dice program and generate a random number. But one of the things we have to work with is how do we get like the range that we want? So like we might want 1 through 6 for a dice, or 1 through 100 for like a random number for a game. So we'll talk about how to do this. So let me actually I don't know why when I right click to end this, it won't end. There we go. Okay. I'm gonna go back over here and I'm gonna do a random number with you, just so we can practice that. So if you want to practice this to save this as an example, you might want this one. Okay. So up at the top, I don't need the math one anymore, so I'm gonna change that to COSC1436. And then you need one more for time. C time. I think it might work without the time one now, but I'll put it in there. So what I want to do, I want to erase this. And I want to use just the random just to show you what happens. So we're gonna do a C out, and we're just gonna use rand. And I'm gonna do end L, so I'm gonna do it a couple times. I'm gonna do it 3 times. There's a purpose for this. Okay, and I'm gonna run it. Those look like 3 random numbers, right? They're all different. But I want you to remember those numbers. Or at least try to remember some of the numbers. Okay? And I want you to run it again. Are they the same numbers? And I want to run it again. Are they the same numbers? Are they the same? Yeah, that's not good, right? So I got 3 different numbers when I did it, which is interesting. But every time I run it, I get the same 3 numbers. Okay. Now, how can we make it so they're not the same 3 random numbers? So we are going to add something up here before we do the random. And it's going to be srand. It's called seeding. And so I have to seed it with a time. And the time is going to be 0. And I can't remember the date. I think it's January 1st, a really long time ago. I can't remember the date of what the actual time is that it's seeding it with, like what 0 is. January 1st, 1970. Okay. It's going based on the milliseconds, like every time so it should be different. Like when you run it again, it should be different because it's seeding it based on time and it's using those milliseconds to generate a new number. So when you run it, as long as you seed it first, you should get, look at those numbers. All 3 of them are different, but when you run it, you should get 3 different numbers when you do it again. Got 3 different numbers. Are we getting different numbers now? Okay, that's better, right? So 3 different numbers, but when we run it, also 3 different numbers, not the same 3 numbers. And so if we don't seed it, we end up with that problem of it using the same start. And so it always just gets the same 3 values. Okay. So what I want to do is I want to not have that really big number for my random number. So you have to think about like what the range is that you want. So I'm going to create a variable called max and min. Okay. So I'm going to create a max variable. If we want to do like 1 through 10, we'll make it 10. And then we'll do a min of 1. Like what range do you want? 1 through 10, 1 through 100, 5 through 50. What do you want it to be? Min will be your starting value and max will be your, you could call it starting and ending or whatever you want to call it. But that's your range. Does that make sense to everybody of what you want? Okay. So you can also get this, the cool thing is you could ask the user for these numbers. Like we could try that in a bit and ask them to enter what range they want. But right now we're just going to put them in there. And then I have to adjust this. I only need 1. I don't need to have it 3 different times. So what we want to do is we want to add on to this. Okay, so right where it says rand, I'm going to add a modulus. And then we put in parentheses max, if that's what you called your max variable. So whatever you call your max variable, minus min plus 1. And then plus min outside of the parentheses. So this should be the equation to make that a range. And of course I have to test it and see if it works. But hopefully I'll get a number 1 through 10. I shouldn't get a number lower than 10 or a number higher than 10. Not lower than 1 and higher than 10. If I do, then there's a problem. So if I just run it a couple times and make sure I'm getting numbers within that range, and then go ahead and switch your range, like try 1 through 50 and see if you're getting bigger numbers. Try different ranges. Are you getting bigger numbers now? Okay, so that would be, I know it's a really weird equation, but that's your equation to get a random number. So try playing around with that a bit and try different numbers and see what you come up with and see if that works. And then we'll talk about some more, make sure everything's okay. If you wanted to practice input, since that's what this is, one of the things in this chapter, you can modify this easily by just asking the user like what the range is, basically, like the upper and lower bounds, however you want to word that. So instead of having the numbers in there, I can just create them up here. And then I can just do like a cout statement that says, enter the starting or enter a min number, however you want to word that so that you know that that's the minimum for your range. Okay, and then cin, that would be your min. And then maybe you can come up with a better cout statement than me on what you're trying to tell the person. Maybe telling them that it's a random number would be a good idea. And then make sure you take in and save in that max. Make sure that you get those values because we talked about this before, that if you're not initializing them up here, that you are at some point putting values in there because C++ will put some garbage in there if you do not. And so make sure that you are getting values in there or you will get one garbage random number. Okay, so at some point we have the max and the min that we were creating up here. And so now when you run it, you get to pick what's the minimum, maybe 50, and what's the max, maybe 9,000. Did you get a number in range of that, hopefully? And then run it again, pick a different min, a different max, and see if you get a number within range of that. You can pick whatever you want. I'm super excited. Okay. Any questions? Okay. Okay. So just give everyone just another minute just to try to play around with that. And this is where I was saying that when you're doing your homework or you're doing a checkpoint and you want to look at your examples, like if I ask you to generate a random number, you're probably not going to remember that equation or like the preprocessor you need at the top. And so this is why having a bunch of exercises would be really good because nobody wants to memorize that. You know, what are the preprocessors or what's the different ways that you can seed it and how do you use the equation. And so just looking at this, as long as you know that you need to seed it, and otherwise you're going to end up with a really weird random number that's the same all the time. So you need to put this random in there. You only need to do one time. If you want to have multiple random numbers, that seeding only has to happen one time, and then you're good to go for the program. But you need to make sure you do that and have the preprocessor at the top, and then do this type of equation. Now, if you don't want to like have variables for min and max, you can just fill in the hard numbers here. Like if you knew you wanted to do 1 through 10, just fill them in with 10 and 1 and 1, and that's fine. But if you want to change them, making them a variable makes it easy to change. You don't have to go back to your statement and try to hard code the numbers again, like whatever numbers you want back in there. Okay. So anyone have questions? Good. All right. So I think I missed a couple slides. Okay, so we were talking about the random, and then, you know, like, when you're using variables, you probably wanna figure out what your variables are doing. And online GDB isn't super helpful, it does have some debugging that you can use, but you can also manually step through and see how your variables are changing, try to figure it out yourself. And so when you're doing it, like, at this point, they don't have any values because they haven't been given anything yet. C++ will put something in there if you don't, but you wanna put something in there yourself. So you still don't have anything because we're just asking you for information, but when you get here and you're taking in the number one, it would be whatever they type in. So let's say they type in 10, you're kind of just filling in the variables. At this point, we didn't fill anything else out, but then eventually we get number 2. At this point, we get number 3. And then when we get the equation, we get the average, right? And then here we have pocket. So you're just trying to figure out how is it going through. Just make sure your program's going through logically, line by line. You don't have something out of order. Okay, and then you can take and break down things. So if you're being asked for different pieces of information, try to break it down and figure out what the equations are for all those different things. So what would the equation be for volume and what would the cost be? And so think about what variables you would need to be able to do all of that. Okay, and then when you're trying to do pseudocode, this is kind of like our pseudocode, except you might not write it this detailed, but basically you're trying to figure out what input is needed. So this first part is, okay, first I need to ask for the dimensions of the crate. I need that information. And then I can calculate the crate's volume and the cost and the charge and the profit. And then what left I want to display. But this part is going to require some calculations. And so you're going to want to figure out what those calculations are. And so first, we are going to figure out what our crate dimensions are, right? Then we're going to calculate, and then we're going to display. So just how do you want to lay that out? So it can look like this, and it can be much less wording if you want. So you're going to need, when you're asking for the dimensions, you can even break it down. Okay, when you say dimensions, what? So length, width, height. So inputs, you don't have to say after either, you say inputs, length, input width, input heights, right? Just so you get those 3 pieces of information, then you're gonna calculate. I would even write what is the calculation right here, so you have it. But the goal of pseudocode is just to make sure you don't forget anything. Like I don't forget to calculate something, or I don't forget to ask for something. You're trying to think of it because if you just try to code without thinking of the problem first, we may forget something or not think. We're just trying to think through the whole problem, like what is needed. Do I have to go find the equation? How do I do this, right? And then what do you want to make sure that you display? Because you might forget to show something. If you're just quickly coding it, you might forget. So it's always good to think about it. And of course, pseudocode can be whatever you want it to be. It could be a short and just kind of notes that you're taking. So when you come back and you're coding, you're checking off, I did this, I did this, I did this, I'm good. Okay. So those calculations could go in your pseudocode. So you have them. So it's just a way to figure out, like, do I need to go look up this equation, or how does this equation work? What's the order of operations for this equation? How is it going to cause problems? Do I need to put parentheses in my equation? Do I need to work about integer division? Those type of things, because when you do it, of course, if you just do it to your code, you'll figure that out eventually. But if you could think about it ahead of time, you can think about, like, when I code, do I want to make the variables a different data type so that I don't have integer division problems with this equation? Or do I want to do a casting like we talked about? Like, do I just want to make the variables types whatever they should be and then worry about casting it later? You're always going to run into it eventually, though. When you see the weird output, hopefully it triggers that. If you didn't think about it at pseudocode level, you'll go back and think about it once you run it and see that it doesn't do what you want it to do. But sometimes you can solve some of those problems just by doing pseudocode and thinking through, like, hey, I'm going to run into, if I have 2 integers here, I'm going to run into having, and I can fix that. How can I fix that? Like, would it be better to fix it this way or this way? Or think about that before you code it so you don't have to take extra time. But, you know, it's all up to you. Okay, so here's the code for that problem that we had. And we had these constants, that's how much cost per foot, the charge and the cost, and then all of these variables to keep track of, like, length, width, height, volume, cost, charge, and profit. And then there's some extra precision here, which is gonna be the 2 decimal places. Oh, this one does have 6, and I don't know. Maybe because if we have 2, because I had both on there. Okay. So the length is gonna input the length, the width, the height, right? And then the volume's gonna multiply them, the cost, they're just all calculations, and then output, and then I don't know why we had both on there, but it should give you the 2 decimal places, you know. And I wouldn't use show point because with the monetary amounts, maybe for the other, like the volume, that would be okay, but for the cost stuff, it's not. So okay. So here you're entering these pieces of data, and then this is just printing the answers. And this is just a different one. Okay, so and the whole point of that was just try to think about it before you do it, basically, right? Okay. Does anyone have any questions? You good? Okay. Okay. So I covered the random, I covered the different math functions. I want to make sure that let's try something and see what y'all come up with because we have some time left. Should have enough time to do it, I think. So I'm gonna put a problem here for you to do, and I want you to see if you can do it because now we know enough to be able to do a calculation. So I want you to be able to convert Fahrenheit to Celsius. So I want you to be able to input the Fahrenheit value from the user. Okay, and then we're gonna have the calculation. Okay, so the calculation is gonna be Fahrenheit. Let me see, I think I have it. Fahrenheit minus 9 divided by 5, I think, times Fahrenheit minus 32. Double check that equation. Where did I put that equation? Oh. So Fahrenheit minus 32 calculation. So whatever Fahrenheit is, we'll just call that F, minus 32, in parentheses, and divide by, we'll say 1.8. And that should calculate the Celsius. And then I want you to display the Celsius. Okay. Well, see if you can try to do that. You can do it with a partner, you can do it by yourself, and then I'll show you what I have, but see if you can do it with, we'll just take like 10 minutes or so, see if you can come up with that, see if you have questions. If you get the input and you get the calculation and you get the Celsius and you feel like, I got it, see if you can format the output with 2 digits of precision. Okay. So work on the formatting if you get the output for Celsius, and then we'll talk about it. So like 10 minutes, we'll talk about it, see how far you guys are, if you have questions. Okay, so I'm gonna go back here. I'm gonna erase this. You don't need a random number for this. Okay, and all I'm trying to do is figure out Celsius and Fahrenheit. So I'm gonna have them enter Fahrenheit, and then we're gonna figure out the Celsius. So I'm going to have a variable to keep track of the Fahrenheit. I'm just gonna call it F, or you can call it FH. Okay, and then I'm gonna have a variable for the Celsius as well. Okay, and then I'm going to ask the user to enter a Fahrenheit value. And so we're gonna say something like enter a Fahrenheit. And in this case, be really specific, spell out the word Fahrenheit so they know exactly what they're entering. And then CN, and I'm gonna save that in Fahrenheit variable, whatever you decided to call that, if you called it F or FAH. you know, you can put end line here, but then your cursor will be, it depends on if you want to end line or you want to keep it. And then put your equation. So if I had a variable called C, I would say C equals, if you didn't declare C up here, you could do it here. But actually, probably don't want these to be ints, right? Let's change those to doubles. So we can have decimals because we want them to probably be able to enter decimal if they want for Fahrenheit, and then we're gonna need a decimal for Celsius anyway. So those should be doubles. So C equals, and then we're gonna do our equation F, if you use F for Fahrenheit, minus 32, and then divided by 1.8. Okay, and then you're just gonna print off the answer, but I told you we'd work on formatting in just a bit, so you may or may not have gotten to the formatting yet. Keep doing that wrong way, sorry. So we'll just print Celsius. And however you want to write that as a sentence, or you just want to write it as the answer, and then whatever you named your Celsius variable, if you called it C. And so if you got to that point, hopefully you should be able to enter a Fahrenheit and get a Celsius variable for that, a value for that. And so hopefully if you type in 32, you get 0, and then type in another number and make sure you get the right number. And then at this point, go ahead and try to add the formatting if you did not get it. Did anyone have questions about what I just did? Was that okay? Okay. So take another 2 minutes or so, try to add formatting if you don't already have that. Remember, you need to add the preprocessor at the top, and then you can do set precision, fixed, or show point, and for that.
I didn't do mine. I did double cell equals, and then I put the equation at the top, like when I first put it in, but I can type the Fahrenheit, the Fahrenheit equation, gives me the same number.
Yeah, be careful. So if you move the equation before you take in the Fahrenheit, it will fill in garbage for the Fahrenheit. Yeah, so make the equation after. So you can declare a C down here, like you could put double C, but you can't put the equation before you take in the Fahrenheit. Otherwise C++ will make it up garbage. So just be careful. Java wouldn't let you get away with it, but C++ will. So make sure if you didn't get to add it, add your include at the top for your formatting. Oh man,
What was that stand for?
that's a good question.
Such a strange word.
I don't know, all of them are.
Maybe it's sad.
Maybe, yeah, that's a good guess, for sure. Like, I know IO string was input output string, so that one I can get. I don't know IO man. That makes sense though. Like input output manipulator. That's a good guess. Yeah, that's why I don't want you memorizing them. I mean, eventually you probably will, but I mean, when you get to like full-fledged, like online GDB isn't as helpful as it could be. Like I hope that when you go to Java, you start moving away from online GDB and you go to a more full-fledged editor. The full-fledged editors will help you a lot more, and it will find like errors as you go. You don't have to wait till you click run. The nice thing about online GDB though is, you know, you can use it on your phone or you can use it on any computer. They don't have to download software. But like when you get to Java, you're gonna want something, or if you get more advanced in C++, you're gonna want something that helps troubleshoot, debug, and helps you a little bit better. Whereas like when I do Java, when I'm doing it, if I forget an import, it will automatically ask me if I want to add it, and it will like add it for me. So I don't have to remember but this won't add it for you. It'll tell you it doesn't know what you're talking about, and then you have to go figure out, oh, I need the preprocessor.
Actually, I forgot the end of man. It actually told me that. Is that what you meant?
Did it
It
fix it?
did.
It didn't fix it, but it told you, okay.
It figured out which one I needed though.
That's good though. That's a step. And they're getting better and better. Every version gets better. But and it doesn't really fix things for you. But yeah, if it gets better and better at identifying what the problem is, which is good. So it's not bad, but it's not as helpful as it could be. Yes.
When you choose the language, there's like C++27 and stuff. What does that mean?
The different versions. So like every version they come out with has more and more capabilities. When you choose the C++ general one, I'm not sure which one you get. Like,
Just did,
all we use is like basic things, so it doesn't really matter which one you choose. But that's a good question. Which one does it use when you just choose C plus plus? Like, I think it doesn't want to confuse you with all the numbers, so it's just like, it probably chooses the new one anyway. That's what my guess, but that's a guess. I don't know. But it's weird, yeah, because you have like every version of C plus plus and Java that comes out in the different languages, they come up with more and more things they add to it. But then the old things should still work, but like there's new features, like, oh, we can conjunct the code this way, or. So as we get more advanced, we might use some of those cool features, but we're still pretty in the basic stages, so. All right, so to format this, all you have to do is again, add this preprocessor at the top. And then you want to add the set precision in here, so. That, you could do it right before you do it, or you could do precision. 2, maybe, and then fixed. I like fixed, you can do show point if you want to, but. Okay. And then you should get 2 decimal places. Okay. So everybody good with that? Think what's in. I'm gonna stop this.